Good afternoon, everybody. Welcome to a very windy Wednesday afternoon of Chem 170 with your host, me, Dr. White. Well, I'll say that real quick. Windy Wednesday. But anyways, welcome. All right, remember, after today's class and lab, I will send out a password and an email to you so you can open up the password protected PDF file for test number 1. You'll have until tomorrow, 4 p.m., give or take. If you're 15 minutes late, I'm not going to dock you, but get it in on time tomorrow to get your answers to me. Remember, if you don't have a printer, just write out the answers. You don't have to write out the whole questions or anything like that. And upload it as a single PDF file to, I was going to say the wrong school, computer system, to D2L, the assignment area. I'd like to apologize because my friend was sick yesterday. I didn't have a chance to upload your scores for the first lab. I'll try and do that next day or so. All right, another thing about test number 1. Since we're not face-to-face, how do I hand you back your answers? Well, I found a couple of years ago when we started doing COVID, Zoom for COVID all the time, by Sunday, probably a lot earlier, but I guarantee by Sunday, 1 p.m., I will email you each individually an email with the points you receive for each question on test number 1. Now, next thing, I'll also have by Sunday, probably a lot earlier, but by Sunday, 1 p.m., I guarantee, I'll also have in Blackboard, wrong school, D2L, your test score. And when the test score is in D2L, and by the time I send out the emails with your points for each question, I'll send out an email and post an announcement that your test scores are available. Next Monday, I will go through test number 1. Now, I cut it out of video. In the past, I used to, well, you got to show up. Then when I did the method video and I cut that out of the main video and I made it private, I'll do the same thing with the part where I go over test number 1. Now, one of the things I keep on saying is, in my world, there's no such thing as a dumb question. And always acceptable question on a quiz. I don't give quizzes on a lab or a test. Well, why did I get these points taken off or whatever? And if you see me in private, which I do, I will be more than happy to explain why I graded something the way I did. And that's something I always will do. All right, so don't forget, when we're done today, I'll send out the email with the password for test 1. You'll have until tomorrow afternoon, 4 p.m. to take it and upload it. In the email, I'll remind you, please don't cheat any way of cheating. I've been doing this on Zoom long enough now that I have very effective ways to find if students cheat. Unfortunately, they work, so please don't. It's rare, but I've unfortunately caught people. All right, let's get to work. Remember, alcohols will be on test 2, not test 1. All right, I ended on Monday with talking about starting with the synthesis of alcohols. And one way, and the only way I'll teach you right now, is if you take a double bond, react with acid and water, you break the pi bond, one carbon gets H, the other gets OH, and it follows Markovnikov's rule. And since I've already gone over this, I'll do a quick problem. I'll let you do a quick problem. This is the only equation or reaction, really, that can be on 2 separate tests. Other than that, I don't do that. Oops. And here's one for you to do. Give the organic product or products for the following reaction. That looks better. All right, I think everybody's done. And when you're looking at a molecule, you look for what's different, what's not a carbon-carbon single bond, carbon or hydrogen atoms should get your attention. Ooh, a double bond. And I'm reacting it with acid catalyst, that's what H plus is, and water. And remember, water for this reaction, think of it as H and OH. And you break the pi bond. Remember, double bond has one pi bond, one sigma bond. You don't break carbon-carbon single bonds, but pi bonds you can. And one carbon gets H, the other gets OH, and it follows Markov-Nikov's rule. And that is the carbon double bond with the most hydrogens gets the hydrogen, the other carbon gets the hydroxyl group OH. This has two hydrogens, this has one. Isn't the math hard in my class? Which is the greater number? Hopefully I'll pick two. Do you break carbon-carbon single bonds? No. So you have 4 carbons across plus this methyl. Here are my 2 carbons of the double bond. I broke the pi bond. The hydrogen goes here, OH goes there. And there are 4 bonds to carbon. And that's the product. And since we've already done this in the problem set for the upcoming test today, and this also can be on test 2, I'm not going to do any more examples. All right, let's talk about reactions of alcohols. Now, here I have an alcohol, and I'm reacting it with sulfuric acid, H2SO4. This little triangle in chemistry means heat. Looks like the top of a Bunsen burner. And I happen to put down, I don't always, this 180 tells you it's really high heat. And what happens is you lose the hydroxyl group from the hydrogen and an adjacent hydrogen to form a double bond. Because what I don't have down here, we don't need to put it down, but I will. Then you also get water. This is called dehydration. That means you lose water. Now, a great Russian scientist figured out a problem, which is, what if you have more than one hydrogen you can lose? Which double bond do you get? And do not write this down. And this reaction follows that great Russian scientist, organic chemist, is Zaitsev, and it follows Zaitsev's rule. Now, in your book, it says, if you bought the book or online, if you look it up, the major product in an intramolecular alcohol dehydration reaction is the alkene that has the greater number of alkyl groups attached to the carbon atoms, double bond. Huh? What? Whoa, what does that mean? Well, intra means inside. if you're going on an international flight from O'Hare, which I have many times when I used to work in the chemical industry, that meant you were going outside the United States. Intra means you're staying inside. So when you have water loss from the molecule, the same molecule, it follows Zay's rule. Now, let me show you how to learn Zay's rule. So if you take this molecule and react it with sulfuric acid, H2SO4, and water, what product do you get? Now, if we look at here, what do we have? We have a hydroxyl group on a carbon, an alcohol, and we have a carbon with an adjacent hydrogen. And if we treat it with sulfuric acid and heat, by the way, this is a real stinky reaction when you run it because you're heating sulfuric acid. You do it in a hood, but the glassware stinks. You get this, and it follows Zay's rule. Now, let's look at Zay's rule. You get the alkene, the double bond that has the most alkyl groups. And in my case, I'm going to teach you the most carbon atoms directly bonded to the carbons of the double bond. So where is an adjacent hydrogen to this hydroxyl group? Well, there's one on here. This one I'll call A. And there's one here, even though there are three, you only need one, is B. Now, if you lose the hydrogen from A, and the hydroxyl group, you don't break carbon, single bonds. And between these two carbons, you'll form the double bond. Now, if you lose from B in the hydroxyl group, you're now this carbon and this carbon, which are these two carbons, you'll form a double bond. And now the question is, what's the main product? Now, I'm going to do something different to help you out. Instead of in real life, one of these you get 90%, 95, the other you get 5%. It's called major and minor products. The way I'm going to teach it to you is your answer should be what's the major product, the main product. How do you figure that out? Well, you need to count the carbon atoms directly bonded to the carbons of the double bond. So in A, we have this carbon, and this carbon. And if I count those, remember, you got to know how to count up to 10 this part of the semester, I have 3. Now, if we look at B, remember, you only count the carbon atoms directly bonded to the carbons of the double bond. And B, that's this carbon. You don't count the methyl groups here because they're not directly bonded. So this has 1. And Zay's rule tells us the molecule with the most carbon atoms, see, they call it alkyl groups, but we'll call it the carbon atoms, is the main product. So this is your answer, A. And that's how you do it. Now, everybody, have your attention. Take a deep breath. Let it out. Take a deep breath. Let it out. Are you nice and relaxed? This is probably one of the toughest reactions I'm going to teach you this semester. Relax. I'm only going to do one example now, this one, because I want you to take the time to go back and look at this and also look at the video when you have a chance. And then on Monday, I'll do some examples, because I've found in the past, if I do this, then I automatically do some more examples. Students have trouble wrapping their hands around this and understanding it. And it's not an easy reaction. Like I said, this is probably one of the toughest I will teach you. So I'm only going to do this one example, and then Monday I'll come back to this and we'll do some practice problems. And I see a question. All right, one of your colleagues just sent me a message, and if your internet goes out and you get knocked off and you have to log back on, that's his life. Last year, my old modem was going bad and I didn't realize it. And I lost, while I'm teaching, my internet went boom, it was gone. I had to log back on. And luckily, I have a great computer guy. I've been using, wow, I've been using Frank since 1995. He's really good. And I called him and said, what's the problem? You need a new modem. And I got one. He came over, installed it. He knows how to do it. And anyways, if you log off, if you get kicked off, don't worry about it. All right, let's go on to the next reaction, which is a lot easier. And this reaction is reaction of an alcohol with hydrogen halides or hydrogen halide acids. HX is an acid. And the reaction is, notice I got colorful. If you take an alcohol, react it with HX, you replace the hydroxyl group with the halogen on the carbon that they had the hydroxyl group, and you also get water. So let's have some fun with this reaction. This is an easy one. And sometimes I'll put it over the arrow instead of a plus. The question is, give the organic product or products. And we look at here and say, what's different? Ooh, hydroxyl group on a carbon, that's an alcohol. And what do we have here? A halogen acid, HX. And here, X is equal to chlorine, bromine, or iodine. Ooh, that reminds me. Time out for a public service announcement. I don't know if you've been following the tragedy going on in Ohio because of the derailment of a number of chemical tank cars in, I think it's East Palestine, or they pronounce it differently, Ohio. And what I wanted to tell you is when I saw what was going on, I know about vinyl chloride, but the other chemicals, there's something called the Material Safety Data Sheet, MSDS. And later in the semester, I'll teach you about that. But you can always look up a chemical in the MSDS and put down chemical name, then MSD or MSDS, or SDS, it's also sometimes called. And Google will bring up your favorite search engine, whatever that is. You're using the new Bing. I don't know, I haven't tried that out yet with AI, but and if you look the second section, I'll teach this later, you'll see how hazardous some of that stuff is. Unfortunately, it is. I thought I just mentioned that. All right, so we have an alcohol, HX. What do you get? You replace the hydroxyl group with the halogen on the carbon that had the hydroxyl group. Do you break carbon-carbon single bonds? No. So I have 3 carbons. My hydroxyl group, alcohol, was on the center carbon, and I'm going to replace it with the halogen, which is iodine. And I know there are 4 bonds to carbon. I also know I don't break carbon-carbon single bonds. And that's how you do it. And later, 2 chapters from now, I'll show you why it is very important to be able to make this type of compound, an alkyl halide. Halide meaning halogen on an alkyl group, RX. And you can find from Mother Nature a lot of alcohols. So to make these type of compounds that are useful, you use this reaction. I better share the fun. And here's one for you to have fun with. Give the organic product or products from the following. And let me remind you, don't forget tonight from 6 to 7:15, I'll have my office hour. If you need help or any questions about test number 1, you can stop by. Also, if you have a question or a problem, always feel free to email me tonight. I'll check my email a couple more times between 7 and 9, maybe twice or 3 times, about 9:30. After that, I call it end of the day work-wise. All right, looks like everybody's done. So what do we have here that's different? What's not carbon? What's not hydrogen? Ooh, oxygen with an H and a carbon. That's an alcohol. And we're reacting with HBr, HX, where X equals chlorine, in our case it's bromine, or iodine. And what you do is you replace the hydroxyl group OH on the carbon with the halogen. In this case, this one. So do you break carbon-carbon single bonds? No, that will be your friend on every test and the final. So I better end up with 4 carbons. The carbon with the hydroxyl group is this one. My halogen is bromine. And I know there are 4 bonds to carbon, so I can put it in my hydrogens. Now, on test 1 that you'll take later today, or I'll be sending out the passport, there'll be 1 synthesis problem. On test number 2, I increased that to usually 2 or 3. So let's do a synthesis problem. And the question is, what do you react with HCl to make that compound? Your turn. And this is really the fun part of organic chemistry. How do you make things? By the way, did anybody happen to drive by a gas station and think of alkanes? Or did you look at Vaseline baby oil and think of alkanes, or a candle half the weight as alkanes? Remember, organic chemistry is all around you, and it won't hurt to think about it outside of my lectures. I stole this part from SpongeBob. And yes, I still like my cartoons, even though when I was a kid, they were better, more violent. Boy, it looks like you people are getting the hang of this stuff. Makes me feel good. Hopefully it makes you feel good too. All right. How do you do this? You look at this molecule, the product, and say, what's different? What's not carbon? What's not? Ooh, halogen, that got my attention. And it's on a carbon. And what am I reacting? HCl, HX. And what do? We start with an alcohol. And remember, X can be chlorine, bromine, or iodine. Sorry about writing that there, or. I have to remember a lot of the students don't know cursive. Took me about a year and a half to figure that out when people, what are you writing? All right, so how do we do this? What's our R group? Everything connected to the chlorine. So since I don't break carbon-carbon single bonds in this reaction, and most reactions, I'll still have a ring, I'll still have two methyl groups, CH3, and the carbon on the ring with the halogen will be the carbon on the ring with the hydroxyl group. And that's your product. There's not product, starting material. And that's how you do it. Any questions? Remember, in my class, there's no such thing as a dumb question. Always feel free to ask questions, and I'll answer them. All right, let's move on to the next reaction. Now, it turns out there's a problem with this reaction, which I'll show you in a second. And because of that problem, this reaction was developed. Unfortunately, I don't know who did. Never did. But if you take an alcohol and react it with SOCl2, that's called thionyl chloride, you replace the hydroxyl group with a chlorine. And just to put it down, because some people ask, what about the rest of that? You get inorganic sulfur dioxide and hydrochloric acid, which is inorganic, and I don't care about in a test. Now, I'm going to write something down. You do not have to write this down. Say you wanted to replace this hydroxyl group with a bromine. And say, oh, alcohol, HBr, and what do you get? Well, actually, there are two functional groups. Look for what's different, double bond and an alcohol. And you just learn this occurs. But hopefully you learned for today's test that if you have a double bond and react it with HX, you break the pi bond, one carbon gets H, the other gets X. In both cases, X is chlorine, bromine, or iodine. And this follows Markovnikov's rule. Well, what that means is you're going to get a mess. Some of this will react, some of this will react, and some of both will. So you're going to get possibility of mixture of three different products. Here the alcohol reacts, here the double bond, and here they both react. And you're not going to get the desired product alone. You're going to have a mess, which you don't want. Well, someone found a way of taking alcohol and reacting with thionyl chloride, SOCl2, and you replace it and make the alkyl chloride. And a lot of times, if you have a choice between bromiodine or chlorine, chlorine's usually the way to go, cheaper and easy. Thionyl chloride will not react with a double bond. So that reaction I showed you, this is the way I would do it. But that's why this came about. Well, let's do simpler ones. If we look at this molecule, and I'll do this one, I'll let you have one, what would be the product or products of the following reaction? And we look for what's different, oxygen. Remember, what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond, to get your attention like that. And we got an alcohol plus thionyl chloride, SOCl2, and you replace the hydroxyl group with a chlorine on the carbon that had the hydroxyl group. Will you break carbon-carbon single bonds? No. So I have 5 carbons. Which carbon had the alcohol? The center one. And that will get this chlorine. And there are 4 bonds to carbon. And that's how you do it. And like HBr or HX, I can put the thionyl chloride on top of the arrow or plus next to the other starting material. Both are the same. Organic chemists use that interchangeably, and I do. So the question is, what's the organic product or product for the following reaction? 3 points each. If you finish early, please be patient. I try and give everybody time to finish. I think I might have mentioned it once or twice. We're in a classroom face to face. I can look around and also say, when you're done, look up and smile. And sometimes a lot of students do. All right, looks like everybody's done. So let's do it. We look for what's different, what's not carbon, what's not hydrogen, oxygen with a hydrogen on a carbon, alcohol. I'm reacting with thionyl chloride. And what happens? You replace the hydroxyl group with the chlorine on the carbon that had the hydroxyl group. This is my R group. It doesn't change. You don't break carbon-carbon single bonds. This all comes along for the ride. Now, this carbon is this carbon, and that's the carbon that will get the chlorine. And that's how you do it. Oh, let's try a synthesis with this one. And the question is, what starting material do you react with thionyl chloride, SOCl2, to make that compound? Like I said, this is the best part of organic chemistry, but I'm biased because I'm a synthetic organic chemist. And remember, synthesis or synthetic is a fancy word meaning to make. And I'll never ask that on a test or final. All right, I think everybody's done. So how do we do this? Well, we look at, in this case, the product, look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond, to get your attention like that. And we have a chlorine on a carbon, nothing else. And I'll show that as Rx. What's my R group? All that. And what do we react with thionyl chloride? And alcohol. And what's my R group? This. So I have 4 carbons plus these 2 methyls. This carbon has the halogen, which will be this carbon, and that will have my alcohol. And I know there are 4 bonds to carbon, so I can put in the rest of the hydrogens. And that's how you do it. So that's the beauty of thionyl chloride. The one thing I will tell you, and in my class, we don't work with it in the lab if we were face to face. Thionyl chloride is a very nasty stuff to react with. In a humid day, humidity, the water in the air reacts with it immediately to form hydrochloric acid and sulfur dioxide. It's really, and you work under a nitrogen atmosphere if it's too humid. Well, you're not going to be working with it. All right, one of the things now that we're getting some good stuff is you should ask the following question often. And that question is, why am I learning this stuff? Well, the obvious answer is, which I found out, but I knew the first day, you're not here to become an organic chemist. You're here because somebody said you have to take the class to get into a program or a school. Well, why should you learn this? Well, let's look at the last 2 reactions. All right, if you see on your screen, a huge industry is artificial sweeteners. And one of the more, one that has a major part of the market is Splenda. Now, the chemical in Splenda that makes it taste sweet but is no calorie is a compound that has a common name called sucralose. Everybody see the structure of sucralose? And the important thing is every bend in the line is a carbon. These are rings, don't worry about it. But here's a chlorine, here's a chlorine, here's a chlorine. Now, why am I talking about this in alcohols? Because how do they make sucralose? Well, here's how. Here's the structure of sucrose, table sugar. And if you look at the difference between this and this, all you've done is taken 3 hydroxyl groups from sugar, sucrose, and replaced them with chlorines. How would I do that? Well, they don't tell trade secrets, but there are only 2 reactions I can think of. One, either they take sucrose and react it with HX, HCl, or they react it with thionyl chloride. And why are you learning these reactions? Because organic chemists use them to make molecules you can use in your daily life and are being sold. Now, an interesting side story, a number of years ago, first of all, I don't know if I mentioned this. If you're a good organic chemist, you're a good cook. I've never met an organic chemist who was good, who wasn't a good cook. Well, anyways, I got into making my own kimchi. Don't ask me why, but it was a challenge. And I gave myself food poisoning, which was not fun. I don't make my own kimchi, I buy it now. But anyways, when I was at my doctor getting help because I needed it, I said, I just read this article in the New York Times about artificial sweeteners. He said, oh, I saw that too. He says, do you think that's valid? He says, well, my doctor at the time, he's since retired, he says, when I chewed gum with artificial sweetener, it upsets my stomach. And I said, well, I think I should stop artificial sweeteners because I drink a lot of tea. I would use an artificial sweetener. I used at that time Equal. And that article was by a, I don't know what's the proper word for a stomach doctor, gastroenterologist or something like that. And he was also overweight, and some of his friends were. He was wondering why artificial sweeteners don't help you lose weight. Well, he identified the, what do they call that? The flora. There's a name for it that escapes me right now. The probiotics in your stomach. After you eat that, you do that by looking at your waste, your feces. And his area of expertise, he could study that. And he had a number of his friends, he tested. And within a short time after you had any artificial sweetener, it killed most of your probiotic bacteria, is it bacteria or whatever? I'm a chemist, not a, in your stomach. And that was not good. And it also made you hungry. So something that's supposed to help you reduce weight and lose weight is not working that well, at least for him. And I found out at that point, because of my food poisoning, I gave up using Equal. And I decided, no, I'll give it up forever, which I did. And now that I'm using sugar, I haven't been gaining weight. In fact, I've been able over the years to lose or keep my weight the same. So that's just my personal experience, but I thought I'd share it with you. All right, let's move on. Now, there's an important reaction of alcohols called oxidation. Before I teach this reaction, there's something I want to go over. This will not be on a test, but I'll use the terminology in class. Not all alcohols are equal. Now, the first alcohol, this is a primary alcohol. I'll never ask it on a test, but like I said, I'll be using that a number of times this semester. And it's abbreviated by 1 and the little degree symbol ROH. Now, the second one here, notice on the carbon with the hydroxyl group on the first one, there's 1 R group. On the second one, there are 2 R groups. Now, they can be the same or different, and that's why you see what's is called R prime. And it's just like in math where you have X and Y. And so you can have the same or different, and this is called a secondary alcohol. And it's abbreviated like this. And finally, if we look at this one, the carbon with the hydroxyl group has not 1, not 2, but 3 R groups. And notice I have R, R prime, and R double prime. They can be the same or different. That's like X, Y, and Z in math. Hopefully I'm not scaring anybody when I say the word math. And this is called a tertiary alcohol. And it's abbreviated like this. Again, this won't be on a test, but I will use this terminology. So if you have a primary alcohol, you have one R group on the carbon with the hydroxyl group, secondary alcohol, two R groups, and they can be same or different. Tertiary, three R groups on the carbon with the hydroxyl group, primary, secondary, tertiary alcohols. Now, the reaction I'm going to talk about is oxidation. And instead of teaching you all the different oxidation reagents, organic chemists use this bracket, O closed bracket, meaning an oxidation reagent. It's something that will oxidize things. And what happens is, notice we have a primary alcohol, and you lose this hydrogen and this hydrogen, and you form a carbon-oxygen double bond. And you'll learn later on, you don't have to write this part down. You form an aldehyde. And I better warn you, Dr. White loves aldehydes, so does Mother Nature. If I look at the clock, I think we got time for show you an example. And the question is, what's the product or products of the following reaction? If I look at this, I have an alcohol, but it's oxidation, and that's a primary alcohol. And when I oxidize it, and that's what bracket O, close bracket, I could, if I were mean, say you've got to learn the different couple of the reagents are KMnO4, potassium permanganate, Na2CO3O7, sodium dichromate, and potassium dichromate too, to name a few. But I'm going to make your life easier. Shh, don't tell anybody I'm being nice. Shh. And what happens is you lose these two hydrogens and form a carbon-carbon double bond. There's still one hydrogen on there, and I like to put it down there. You could also write it this way. I think this looks cooler. Dr. White tries to be a cool dude. So what's my R group? This. So I have my R group, and this carbon here, which is this carbon, becomes that carbon, which is double bond to hydrogen. This counts as two bonds, and I'll put in my hydrogens because I know there's 4 bonds to carbon, and that's how you make an aldehyde. And turns out aldehydes play an important role in our life. But speaking about that, I went a minute over. So let's take a 5-minute break, and we'll come back, and I'll go over some more organic chemistry, and we'll do the lab. See you in 5. I'm back. Are you guys back? All right, let's continue. One thing I shouldn't point out, today being a Wednesday, normally if we were face to face, I'd lecture for 50 minutes like I just did, and then we go into lab. But since we're doing the lab online, the way I have it set up, I can give you more time, which helps you. I could get out here early, but I'd rather spend it with you and to make sure you do well. All right, we were talking about oxidation of alcohols. I just gave you this reaction, showed you how to do it. So it's your turn. And the question is, what's the organic product or product for the following reaction? I should point out, I use these oxidation to make aldehydes for my PhD thesis. I think everybody's done. So if we look at this molecule, what's different, what's not carbon, what's not hydrogen? Ooh, oxygen with a hydrogen and a carbon, but we're oxidizing it. That's what bracket O, close bracket. So I know I have to determine what kind of alcohol am I using. And this is a primary alcohol. And if I oxidize it, I'll remove this hydrogen, this one, and form a carbon-carbon double carbon oxygen double bond and get an aldehyde. And let's see, not next chapter, but the one after, we'll talk about aldehydes. And therefore, what's my R group? This. Another way of thinking is you break carbon-carbon single bonds. No, I have 3 across plus this methyl. This carbon, the alcohol, is this carbon, which is this carbon, which becomes this carbon, which is a double bond to hydrogen. And I know there are 4 bonds to carbon. And that's the product. Oh, let's have fun with a synthesis problem. And now the question is, what would you react with an oxidizing reagent, bracket O, close bracket, to make this compound? Your turn. Oh, that's not what I wanted. And let me remind you, if you're not done, don't pick the other choice. Just wait until you're done to click on yes. All right, I think everybody's done, so I'll give everybody another 15 seconds. All right, now if we look at the product, what's different, what's not carbon, what's not hydrogen? Ooh, oxygen, double bond to carbon with the hydrogen, and carbons on it. And I'll call that R. My R group is this. And what do we oxidize to make this, which is an aldehyde? And the answer is a primary alcohol. Well, my R group are these 4 carbons with this carbon here. Then I'll have this carbon here, and that will have an alcohol. Now, the other way of thinking about it is I have 1, 2, 3, 4, 5 across plus a methyl, 1, 2, 3, 4, 5 across methyl. And this carbon here is this carbon here, which is this carbon here, which is this carbon here. And I know there are 4 bonds to carbon, 4, so I can put in the rest of the hydrogens. And that's how you oxidize it. And that's oxidation of a primary alcohol. Now, you can also have a secondary alcohol. And if you oxidize it, you get a ketone. I have it drawn this way, but I'll show you. It works better for students. My software likes to do it that way. This is a secondary alcohol. If you oxidize it, and that's what the O in the brackets means, you'll lose this hydrogen, and you'll form a carbon-oxygen double bond. And you'll learn a couple chapters. This is a ketone. And Dr. White, Mother Nature, love ketones too. I really do. My PhD thesis was on that. I used a ketone in my last patent. So I like them. They're fun. So let's try one. Now, if we look at this, there are 2 ways I tend to write this molecule. This is one way, and sometimes on a test, I might have written it this way. And they're both the same molecule. And what's different? Hydroxyl group on a carbon, an alcohol. But notice you have 1, 2 R groups on that same carbon. I can call one R prime. Same thing up here. R, and this is R prime. Doesn't matter what you call R and what you call R prime. When you oxidize, a secondary alcohol, you lose this hydrogen, just like a primary, and that hydrogen on the oxygen, and you form a carbon-oxygen double bond. And this is called a ketone. So if I look at this, here's my carbon with the alcohol, lose that and that. My R and R prime will still be bonded to that carbon, excuse me, and it will have a double bond. And if you wrote it this way, it's really the same molecule. Here's my R group, carbon double bond oxygen, R prime. And that's how you make a ketone. And if you notice, I'm smiling because Dr. White loves ketones. And here's one for you to try. Now we're getting into some really good stuff. Remember, just vote if you're done. If not, hold off on answering yes. If you're done, answer yes. All right, looks like everybody's done, so it's my turn. We look for what's different, what's not carbon or hydrogen, hydroxyl group on a carbon. It's got carbons here and here, and that's a secondary alcohol. And here I put the hydrogen where I normally put hydroxyl, so I better be consistent, doesn't matter, but not to confuse you. And when you oxidize it, remember that's what bracket O close bracket means. Use this hydrogen, and you form a carbon-oxygen double bond, a ketone. And R and R prime come along for the ride. So I can call this R, R prime, doesn't matter which you call which. And notice I have 1, 2, 3, 4, 5 carbons across my R group, the carbon, this one right here. Then my R prime, 3 carbons. I've got 5 across. This is this carbon, which becomes this carbon, which means I will have this. And I've made a ketone. And like I said, Dr. White's partial to ketones. So is Mother Nature. Now, let's look at something different. Not different, but if we look at this molecule, if we oxidize it, I'll do it. And we say, oh, wait, well, I've got what's different? Oxygen with a hydrogen and a carbon. It's an alcohol. I'm oxidizing it. What kind of alcohol is this? Well, notice you have a carbon here and here attached to the carbon with the hydroxyl group. Remember, we don't show hydrogens on a ring, but there's one on the carbon with the hydroxyl group. And I can say a ring like this is really a secondary alcohol. But in the ring, R and R prime are connected together, like this. And when I oxidize it, I lose this hydrogen, and form a carbon-oxygen double bond, a ketone. Well, do you break carbon-carbon single bonds? No. So I'm still going to have my ring. This carbon becomes this carbon, which is this carbon, which is this one, and we show it like that. And that's called a cycloketone. Dr. White really loves cycloketones. My PhD thesis was on that. So that's how you use a secondary alcohol when it's in a ring. It's your turn. All right, my turn. If we look at this molecule, what's different? What's not carbon or hydrogen? Hydroxyl group on a carbon. And this carbon, notice, has carbons here and carbons here, which I can call R and R prime. And the ring, they're connected together. And we're oxidizing this. So this is a secondary alcohol. And you lose this hydrogen, this one, and you form a carbon-oxygen double bond, and we made a ketone. Now, do you break carbon-carbon single bonds? No. So the same thing as saying the R groups are unchanged. And this carbon is this carbon, which is this carbon, which becomes this one. And we show that like that. And that's how you make a cycloketone. Now, notice both a primary alcohol has hydrogens on the carbon with the hydroxyl group that you lose to form the carbon-oxygen double bond. Same thing with a secondary alcohol. What about a tertiary alcohol? And here we have a tertiary alcohol. If we oxidize it, what's the product? No reaction. Tertiary alcohols cannot be oxidized. Now, as I said the first day of class, I teach by my golden rule of teaching. I don't do my students what I didn't like done to me. And if I'm taking an organic chemistry test and says give the product or products, and the answer is no reaction, in my mind, that's not fair. You say, what does it make? Well, it should make something. Therefore, this reaction will never be on a test, will never be on the final, because you're not going to make anything. We'll talk about it in the lab, but no reaction. And if you notice, I have note tertiary alcohols cannot be oxidized, no reaction. All right, let's briefly talk about alcohols with more than one hydroxyl group. And click, I'm turning the switch, will this be on its S, to the off position. Now, glycols are where you have two hydroxyl groups in a molecule. And the simplest one is this. And the common name, and you don't have to know this, is ethylene glycol. And ethylene glycol, when you mix it with water, roughly a 50-50 mixture, we call that antifreeze. And because of the colligative effect of ethylene glycol and water, it lowers the melting point real lot and raises the boiling point, which in your radiator, you just have water. If it got up to 100 degrees C, it'd start boiling and blow up your radiator. If it got real cold, below 32 degrees F or 0 degrees C, then your radiator would freeze. It was just water and bust open. Well, with ethylene glycol, that changes it. Now, glycerin, which we'll talk more about later in the semester, you have three hydroxyl groups. And it turns out your body makes glycerin when you digest fats and oils. We'll talk more about that when we get into fats and oils. I showed you the structure of sucrose, table sugar, had all these alcohols and hydroxyl groups. And just because something is named alcohol doesn't mean it'll get you inebriated. I've yet to see anybody get inebriated, meaning drunk, by consuming a number of tablespoons of sugar. Table sugar won't happen. Now, the last one, polyvinyl alcohol, has this structure, and again, switches off. It's also called known as PVA. And that has this repeating unit, CH2, CHOH, another CH2, CHOH, and N here, how many times is it repeating, is anywhere from a half to a million, 500,000 to a million. And most of you probably have polyvinyl alcohol in your house. No, I don't. Yes, you do. If you take polyvinyl alcohol and mix it with water, it gets this white, and I'm going to be very scientific, goopy stuff, and we call that Elmer's glue. When we get into polymers later in the semester, I'll talk more about it. And I actually worked for Borden Chemical, which at one time owned, manufactured Elmer's glue. When I got there, they had just sold off that division. I worked in another division of Borden Chemical. All right, switch is still off. Let's talk about phenols as antioxidants. Now, air has oxygen. Oxygen can oxidize things to form what's called a radical. Now, radical is a carbon with one electron on it, not a negative charge, and they're very reactive. I could do a whole semester graduate school level course on radical organic chemistry. We're not going to really touch it this semester in this class. Now, it reacts with many things, including fluid and lubricating oils. And reaction of radicals break down those foods or lubricating. Now, I don't have it. I'm not going to show you. Now, phenolic compounds react with radicals to form a phenolic type stable radical that doesn't react. And how many of you have heard antioxidants are good for you? And they are, at least I believe, medical science. I'm not I don't do research in that area. And the theory, one theory is that by trapping radicals that are forming in your body with the antioxidants and sort of neutralizing them, it's not really, but a way of thinking of it, it stops it from doing damage in your body. And I saw a couple of years ago, some medical doctors had proposed that radicals are the cause for aging. Is that true? Don't know, but I get my radicals. Now, before they changed the packaging of potato chips to the one now where it stops oxygen from getting into the package, the bag of potato chips. By the way, Dr. White loves Lay's sour cream and onion potato chips. That's dangerous stuff around me. But anyways, they'd put in two oxidation reagents, BHA and BHT. And that would keep the oil from going rancid. How many's ever tasted or smelled rancid butter or crackers and all that? You can smell it real easy. And when I was in grad school, I would tell my mother, well, I should have some more potato chips because the antioxidants in there are good for me. She didn't buy that. All right, let's talk about new functional group time, and that's thiols. And thiols are what's called the sulfur analog of alcohols. Alcohol, if you replace the oxygen with a sulfur, you have a thiol. And I'm not going to go through the nomenclature. You don't need to know it. But for thiols, the same of alcohols, except replacing the OE for OL, use THOL. And the most important thing about thiols is they stink. Oh, do they, stink. Now, I learned it, and I think it was about 20 years ago that IUPAC changed it. They used to be called mercaptans. So if I say mercaptan, bear with me. All right, now I'm going to skip this slide and move to this one. What's the most stinky thing you can think of? A skunk. It's a defensive weapon. You've ever been around where a skunk lets loose? Whoa, you know it did. And the switch's still off right now. And these two thiols and the remainder as water is the skunk's defensive weapon. And like I said, thiols stink. Now, you also find thiols in garlic and onions, which I like. Dr. White's an onion lover and garlic lover. But let's talk about something sad. Back in about 1935 in this town in Texas, they had a horrific explosion in the local school. And it was brand new, pretty new. And it killed, I think, about 130 students and teachers, and it badly burned a lot of others. Switch is on now. You should know this. And because of the tragedy that happened, the Texas state government created a commission to make natural gas safe. You're going to say, wait, I can smell natural gas when there's a leak. And what happened was, in the high school, there was a gas leak. There's two stories. One, when they built it and it was new, the pipes, some of the gas pipes were leaking, and eventually filled the whole school with natural gas, and a spark just blew it out. If you have a light switch and you turn it on, a spark goes on there. I've worked in explosive areas of chemical plants where we have explosive proof or spark proof lighting switches and even telephones, because if there was a spark, it'd blow up and you'd be dead. Well, what this commission, and you should know, came up with is, in order to be able to, people could tell that there's a gas leak, they came up with a great idea that's still being used today in the United States. And I don't know about the rest of the world. I think it might be, but I don't know. They put a thiol into the natural gas. And what thiol was that? T-butyl mercaptan. Did it again. T-butyl thiol. And you don't have to know the name, just they put a thiol in there. And that thiol stinks so much. How many of you have ever smelled a gas leak? You can smell it like that real quick. they only put 1 to 4 pounds of the T-butyl thiol per billion pounds of natural gas. That means there's only 4 ppb, 4 parts per billion of the thiol in there, and that's how stinky it is. And that makes it safe, because if you know, you can smell it, you know there's a leak. In fact, years ago, when I was in grad school, we'd have once a month a fire drill, and you go out, evacuate the building. They do it at UCC too. I know about once a month. At Michigan State, unfortunately, I'm a graduate of Michigan State. That's where I got my PhD. And the tragedy of this happened hit home because I know those areas. It's been a long time since I've been to school. But anyways, we go out and there'd be a couple hundred people in the building. It was like 2 blocks long, 5 stories, and a basement, sub-basement, and a sub-sub-basement, all 2 blocks long. It was huge. And 10 minutes, all right, all clear, you can go back. Oh, one time in November, fire alarm went off in a chemistry building, you leave. And I put on my jacket. I happened to be in my lab, not teaching, luckily. And I went out, and organic grad students were in one group, inorganic physical. We're there 5 minutes, 10 minutes. It's cold, and there's light drizzle, so it's miserable too, even though I had a hood. So I had my jacket on. For about 15 minutes, some firemen walked by, and one of our group, I was in the group, he walked by, asked, "What's going on?" And he said, "Gas leak." And after a couple minutes, one of us said, "What idiot poured a thiol down the sink?" Well, that's what happened. Somebody poured a thiol down the sink. That's not the way you dispose of it. It went all the way to the sub-basement, and there, one of the water traps was dry. The odor came out. A janitor down there smelled thiol. We didn't say that, gas leak, and called the fire department. Did the right thing. But you should know, hint, you should know that a thiol is added to natural gas so we can smell a leak, and because of that tremendous tragedy. And it's new chapter time. Let me do one thing, close that. And that new chapter deals with ethers and epoxides. Now, what is an ether? Well, an ether is where you take an oxygen, and instead of a R group and an H, you have 2 R groups on it. And this is called an ether. So we have an ether. Now, nomenclature, I'm just going to teach you the common nomenclature, not the IUPAC, because nobody uses that most of the time for ethers. And again, this is an ether. And you name So how do you name ethers? Common way, name each R group as an alkyl group it is, and add the word ether at the end. So if we look at this, what do we see that's different? An oxygen. And it's got carbons here, oxygen, carbons here. Again, R and R prime tells us they could be the same or different. And how do you name this is an ether? Now, this R group is a methyl. This R group is N-propyl. And it's an ether. And that's how you do it. Now, since this is a common, there are no rules. You could have just easily put N-propyl methyl ether. So you name each R group as the alkyl group it is and add the word ether. And here's one for you to do. What would be the common name of this ether? Well, I think everybody's done. And what do we have? Oxygen with carbons here and here. Ether. This R group is ethyl. This R group is isopropyl. And it's an ether. Now you could have this is easily written isopropyl ethyl ether. Now let me show you why organic chemists usually use common names for ether. Switch is totally off for this RO group is called an alkoxide. So for an ether, you find the longest chain that has the RO alkoxide on it. And that's this one. That's butane. And here, this is called methoxide. That's on carbon 1. Again, switches off for this. So that's 1-methoxybutane. The common name would be methyl and butyl ether. And that's why we normally use common, not IUPAC. All right, I think it's time to do the lab. Because remember on Wednesdays, we get out early. If we'd been face-to-face, you'd be in the lab. And this lab, because it's the first test around the first test, I made it real quick. And what lab will that be? Let's find out. Let's first open it up. Hold on one second. I thought I had it open. I didn't. All right, everybody see aromatic compounds on your screen? All right. As I mentioned when we started this, aromatic compounds are found in spices and herbs in our daily life. And through the 14th and 1700s, wars between European countries were fought over the spices, control of them, and the lands where the spices were grown. And it was quite lucrative. Now, many spices and plant extracts have common chemical feature, and that's they contain an aromatic benzene ring. And some of these molecules include eugenol, isoeugenol, vanillin, benzaldehyde, and trans-cinnamaldehyde. Now, if we were face to face, we'd be in the lab, and I have these out, samples, for you to smell. Obviously, you're not going to do that today unless you have some of these at home, and I'd recommend. Turns out your nose is one of the most sensitive analytical instruments around. And I'll talk later on in the semester. I think probably one of the hardest problems I ever had to solve in the chemical industry dealt with odor, and I'll talk more about that. Now, what you will be smelling is cinnamon, cloves, nutmeg, vanillin, and benzaldehyde. If we're smelling this, you go in there and you take the liquid or the solid. And if it's liquid, you go like this. Or what I actually do is I put some of the benzaldehyde, that's the only liquid, and put it on paper towel, little pieces, and pass it around. And then you record your observation. Now, most of you don't have cloves, so I'll have that. But if you've ever smelled cinnamon, nutmeg, vanillin, why don't you write down what you think it reminds you of? And each person is going to have a different answer because you have different life experiences. Now, one of the things, if you look at cloves, a lot of students in the past would say it reminds them of, your Christmas ham. But I also have dentist office. Wait a second, why dentist office? Well, unfortunately, due to genetics, I have had a lot of dental problems. So my sisters, my mother, anyways. And if you ever have where they inject the anesthetic into your gum, the nerve when they got to do stuff, if you got a good dentist, they'll rub something on the gum, a liquid, and it will numb the gum. So when the needle goes in, you don't feel it. And originally, for many, many years, now they're using something different, but for many years, they used oil of cloves. The chemical in cloves that they extract will numb your gums. Now, in this lab, here are the questions. I'd ask you fill these out. If you don't have one of these chemicals, one of these things in your home, just write down, leave it blank. But the questions, please answer. Now, on question 2, I helped you out, and I would have done this face-to-face on a whiteboard. The key chemical in cloves is eugenol. The key chemical in cinnamon is trans-cinnamaldehyde. That's the common name, not the IUPAC. In nutmeg, it's isoeugenol. In vanilla extract, it's called vanillin. And benzaldehyde is just benzaldehyde. Now, interesting thing. How many of you have ever smelled either maraschino cherries, the ones that glow in the dark, the red ones like they put on a sundae, or Dr. Pepper, or almonds? If you smell any of those, what you're smelling is the benzaldehyde. And not all people can do it, but I can. When I smell benzaldehyde, if we're in the lab, you do try this too, I can smell both the cherries, which is also in Dr. Pepper, and the almonds. And if you don't know almond mascarpone, that's a really sweet stuff they put in certain sweets in Europe. and it's dangerously good. And so what you need to do is draw the structure here. How do you find it? Like for eugenol, go to your favorite search engine, put that name in, and afterward type chemical structure. And one of the first 3 hits will show you the chemical structure. Same thing for all the rest. Don't forget the answer number 3 at the bottom of the page. What's your favorite spice or aromatic chemical? Mine is vanilla extract, even though benzaldehyde is pretty close, but vanillin and vanilla extract. And with that, I'm done for today. We're done for the week. In about 5 or 6 minutes, I'm going to be sending out the email with the password for test number 1, which you can download from D2L. Remember, have it finished and upload your answers as a single PDF file by tomorrow, 4 p.m. By Sunday or earlier, I will have the grades posted in D2L, and I'll also send out an email that has your individual points for each question. On Monday, I will go through the whole test. I do that with all my tests, and I'll go over all the answers. And I'll cut that out of video, but I'll also post it as a private video, and I'll send out the link to that in an email after I do it, obviously. So with that, have a nice rest of the week. Hopefully you had a nice St. Valentine's Day yesterday. And with that, I'm done. So gang gesund. Don't forget, I have my office hours. I'll say it again. I have my office hours tonight from 6 to 7:15. If you have any questions, stop by. And I'll say, remember in Yiddish, it means go in health. And the pandemic is still with us, unfortunately. I'll say, gang gesund, goodbye. I stole that from Granny.